So today I'll be explaining the code of palindromic partition, and it's a medium kind of question on LEETCODE and difficult I guess on GFG. So I'll just explain the code in this for explanation and for all the intuition. You can watch video of Sumit Bhaiya. I'll link that in the description, like best ever explanation you can have of this question. So I'll just explain this code because what he had done is he explained that into Java, but I did in Java and all on his platform also pep coding. So for lead code, I prepared this solution and with the same logic what he told. And what I'll do here, I'll just explain this whole logic of these four functions. So I'm assuming that you must be already knowing the logic and all the question, how it's like the logic which Sumit Bhaiya has told. So what I need to do is first I was giving this partition function with string. A single string was passed. For example, A, B, A, B, A. A single string was passed in input, and you already know that what I need to do. So this was passed. I created. Let me just explain this very beautiful concept of 2D vectors, like how we do in matrix now. The same thing. 0 1 2 0 1 2, the 2D array, which you also call matrix. The same thing is there in vector, alright? But in vector, in this we are using the string thing, like I'll explain how. I'll start with a simple and beautiful example. This is a chocolate which we all have eaten, named Kit Kat. So in Kit Kat, we have these wafers. We have these wafers sticked together. These kind of wafers are there, sticked together. Ignore my drawing. And these different chocolate wafers can be separated out easily. Like if you'll break them, they can be separated out. So the most efficient way to visualize a vector, like in this way, I remember it. You can use any other way also, but for visualizing 2D vector, nothing can be better option than this. These are wafers, okay? And if you combine them, they form an Kit Kat. The wrapper is called Kit Kat. So these wafers are filled into Kit Kat. The outer body is known as Kit Kat. The inner portions are known as wafers. So same thing we need to do here also in our question. Like whenever you are asked for 2D vectors are basically list of list. Like they are strings. They can be of anything. I'm just explaining what is needed in this question. They can be of any type like int or something, but I'm explaining about string. So these are strings. These are strings like A, B, and A something. This is a single string, and similarly we have five strings in our answer. For instance, we have different five strings, and these all are strings at once. I'll explain what I'm saying. Here you can see we have AAB. It's an input string, and what we have in output is this is a string in itself. This is a string, which is this is a list in itself. You can see this is also a list, and this whole thing is also a list. So we need to return this whole thing. Like we need to return the whole KitKat from this function, and we need to fill these wafers with our values. Like for example, if it's A, so we need to fill these wafers with A, B separate, and then A, B. If you have already seen the video, you must be knowing the logic. So I won't explain logic here because Sumit Bhaiya did that like quite well. So let's jump back to the, let me just erase this all, just a second. Yep. So let's jump back to the code. So our code says is we were given a string this, and we declared our KitKat empty 2D array, and we declared our wafer, which is a single, like this thing is a 2D array, you can say, kind of. This thing is a matrix, kind of. Matrix is more like 0 1 2 for integers, but this vector is for string, so you can assume it like this. This is the whole KitKat and these are the wafers. So KitKat is obviously 2D and wafers is single dimension string. So this is a single string, the wafer which you have in KitKat, and 2D is consist of so many wafers. So this ignore this. We won't use this thing. Ignore this. No need of this. Now I've passed these three values to my function, to my solve function. What it will do? It will just take the string which was passed from the function and wafers, the empty, and KitKat is also empty because it's like currently it's. I'll just draw a big KitKat here and I'll start filling the values so you will be more comfortable with that. It's a single wafer. It's second and third wafer. Okay. So you can name it 0, 1, 2, 3, like something like that. But no need because vector can automatically do that. So solve we have passed string. Let's just write what string we have currently. str we have a b a b a, I guess this was the string, and here also this one is like a kind of short example. I can take this, but this is kind of short. Okay, let's do it. A b na. Okay, let's just write a b here. Ignore this. We have a string a b, and what we have passed a empty wafer, which is a empty string, and a empty 2D string. We have passed these two things to the solve function. Solve function, we created all these functions except this partition function. This was provided us by LeetCode, and we created all these functions which you are seeing right here. So let me just point them out. It's a single function. It's a single function. I know, just a second. It's a single function. Okay. It's another function which was passed by LeetCode, and this is a function. So first function, second function. This is already pre-declared function partition. We just did this solve thing and return KitKat. Return KitKat. Just a second. Return KitKat means this solve will give us the answer which we are looking for, and this return KitKat will just return whole KitKat, which is AA, which is this thing AAB and AAB. The difference you already know if you have seen the video. If not, just go and see it. So let's discuss about this solve function. I already told you that I have passed a string, a string, and a vector of string type and a 2D vector. I have passed a string here, this is vector, string vector, and this is 2D vector. These both are passed by reference. So if we'll do any change in them, it will directly reflect in here. So base case ignored. Sorry. This is the base case, ignore it for now. Let's directly jump into this thing. What this thing does is, how should I explain? I'll explain over here only. I have started a loop from 0 to n. Okay, I started a loop from 0 to n. Now, what I need to do is, I have this string AAB, and you know that we need to take out the first thing. We need to check it out if it's a palindrome or not. If it is a palindrome, then what we need to do is, it is our potential answer. And in recursive tree, if something is potential answer, then from there only we draw its tree. But in the end, we need to come back here and look for the other path also. Like I'll explain this tree thing to you in a very beautiful manner. Like just imagine this pop back function, because I was so confused about this in my, just a second. Yep. Just imagine you are a guy, you are standing and you are a contractor. Okay. Just imagine there are two paths where you are standing. There are two paths diverging, and you have one truck. You have one truck in which a driver is sitting, and his task is to collect the sand from this is the sand. This is sand dunes. Collect sand from here and dump it to this site. This is a site 1, this is a site 2. This is site 2, this is site 1. Our truck driver takes the sand, goes to this way, dumps, and comes back, and when it comes back, it's obviously empty. and we do not care about how it dumped the sand. Either it dumped on the particular location or it dumped it somewhere else. Like we do not consider about this. Just consider about your path. You have two paths and you have sent something to this path. When this thing comes back, it should have a empty truck. Like this should be empty. Then only you can send it to the other way. Remember this concept, and in recursion tree you'll never ever get confused about the pop back thing, like why we are pop backing, because in recursion we always have option like A, and now I have option to include A or to include B. Just for example, I have included A in my A only. Okay? Now this thing goes like A, this becomes this. But when I come back to this thing, I need my A back. I cannot proceed with AA because my current string is AA. I cannot proceed with AA and add B. It won't be fair. I want my A to be empty, then only I can go ahead and add B to it. So for this empty thing, we use pop back. Just remember this concept, it will be helpful. So we are here. We took this A into our prefix using the substring method, and we took this rest of the string. This rest of the string, A, B rest of the string. I'll just write here. Here we have A and here we have AB. Okay. This prefix A is passed into is palindrome function, which is a function we have created to check if a number, if a string, if a digit is palindrome or not. So we have passed the string. String is currently A, and we need to check if it's palindrome or not. If it's true, if it's a palindrome, and what we need to do, this is our potential answer. Sorry, this is our potential answer. What we need is a answer which is a substring. So a single A is always a palindrome. A single digit, a single string is always a palindrome of itself. So it's a palindrome. What we need to do, we need to push it into a wafer. Our wafers was empty. Sorry, I've drawn it here already. Yep, our wafers were empty and our KitKat was empty also. So here A was pushed back. A was pushed back as a potential answer in our wafer. And our KitKat now have this A in wafer 0. Hope you are understanding this thing. Then it's pushed back in a wafer because it's a potential answer. And once all these will be filled, we'll return this whole, what you say, this KitKat thing to the, return statement. Now, again we are calling the recursion starts from here. We'll call this remaining of the string. Now currently we have in prefix we have A and rest of the string, what is rest of the string, AB. So we have these two string which we took out from AAB. Okay, so we'll pass these ROS, which is remaining of the string. Prefix we have already checked that yes, this A thing is a palindrome. Will pass wafer and will pass KitKat. The same thing we have passed there, string wafer KitKat. This is a string wafer KitKat. The difference is this string is now remaining string. Earlier the string which we passed here was AAB. Now we took A from it and the string we are passing now is only AB. This is remaining of the string. Okay, no worries. This goes again to this thing. Okay, this comes down and again the same operation starts with the AB. Prefix taken. Okay, prefix is A. Is it a palindrome? Yes, it's a palindrome. If it's a palindrome, push it back to the wafer. Okay, we'll push it back to the wafer. We'll write A here. Okay, no worries. What we are left with? We are left with the only string B. Okay, then pass B, wafer and KitKat. Okay, we have passed B, wafer and KitKat. Solve. This thing is now contain B, the wafer which is already filled with AA, and a KitKat in which a wafer is filled with A. Hope you are getting this point. Then same things come here. It will check that what's the prefix. Prefix is only B now. There is no remaining of the string. Prefix is B. Okay. This will check if string size is equals to 0. After the prefix size, there will be no string left. So what it will do, it will pass this wafer into KitKat. Just a second, let me explain this again. I know you won't be getting this. This B was passed. Okay, this is prefix, nothing is left here. This prefix is palindrome or not? Yes, it's a palindrome. Then pass it into our wafers. Okay, push back into our wafer. I have pushed back into our wafer. This B. Okay, now pass the remaining of the string. What is remaining of the string? 0. Nothing remains, wafer and KitKat. So once you have passed nothing and string size becomes 0, so this wafer will be pushed back into the KitKat. Like imagine it this way. This KitKat wrapper was empty and open from one side. We were preparing a wafer. This wafer got prepared AAB, which is our potential answer. Then insert it into our KitKat. This was inserted AAB. This should be our potential answer. Let's check AAB our potential answer. So this way, this whole like backtracking thing and this wafer dot pop back. When this comes out from the loop, like you will be drawing this recursive tree, na? And you have hit the base case here. So when you'll come back here, you need your original value to be back. That's why I popped back the previous values. Pop back the previous values so you can go to the other way. So you can start for this answer. You need to watch Sumit Bhaya's video for understanding all this, but this was the whole code explained, and this was same on GFG and LEETCODE. Thank